Okay, so question 3 is about radioactivity. Let me circle that. Alpha, beta and gamma are 3 types of radioactive emissions. Which statement describes these? So we can see, well, the first bit is, are they ionizing or are they neutral? Well, they're definitely not neutral, they are ionizing. And the next part is, do they come from a stable nuclei or an unstable nuclei? And we know it's an unstable nuclei. And this is just going back over RSDUN. Radioactivity is the random and spontaneous decay of unstable nuclei. So just make sure you know that definition off by heart. Okay, next one, fluorine 19. So F919 is an isotope and it's stable. It also has some radioactive isotopes. So for example, 920, 921. And we know we've added some more nucleons, we've added some neutrons to the nucleus, and that's going to make it more unstable and therefore radioactive. So describe a similarity. They've got the same number of protons, or the same atomic number, or the same proton number. So the smaller number of the two is the same, and the difference is they've got a different number of neutrons, or a different mass number. Next one, we've got a Geiger-Müller tube, and it's connected, and it's used to measure the activity of a source of beta radiation. There's an aluminium sheet in between, and we know that that will stop beta. We know that. So it's switched on, and after a minute, it shows a count of 268. The aluminium sheet is taken away. It's set to 0 and switched on again. A new count is taken for 1 minute, and it was a minute up here as well. So yeah, same amount of time. Why will the new count be greater than 268? Well, if the aluminium sheet's taken out of the way, woohoo, then beta will be able to pass through. So there's no aluminium to block or absorb the beta particles. So more, and you can see that there, beta particles will reach the Geiger-Müller tube. The next one, the beta source is then taken away and the count is set to 0. Why would there still be a reading on the counter? Well, we know we've got background radiation around us all the time from the rocks and air. So background radiation is in the environment all the time. State the SI unit for activity. That's a becquerel, capital B, little q. And then we've got radium-223 is a radioactive substance. It's an alpha emitter. The half-life is 11 days. It contains 1.7 times 10 to the 23 nuclei of the radioactive isotope. Calculate the number after 33 days. So our first job is, well, 33 days over 11, we need 3 half-lives. And then we're going to take this value and then half it 3 times. So that's what that looks like. Remember, underneath your first one to put ST. And then we can see that our final answer is 2.125 times 10 to the 22 nuclei. And that's question 3 done.